All right, so what is Arduino Cloud? Arduino Cloud is the platform that they have started to develop to allow all sorts of devices to connect to Arduino boards and other various microcontrollers. The Chromebooks will need this cloud to work. They don't have all the drivers to be to give as many options as what a full desktop solution has. But the boards that we use, the Uno R4 and the Uno 3 and things like that, those are all compatible with Chromebooks, so that way we can have this be as seamless as possible. If you go through this and you feel like you need more information, there are plenty of little tutorials that show how things work and where to find stuff, and you're more than welcome to do that. But we're here just to kind of help you focus on the things that we'll be using in this class. So on this tab on the left side, we have sketches, devices, things, dashboards. Anything below that we don't really care about for this foreseeable future. Now these other elements in the later, even in this first section, they will come in at some point, but for now let's just focus on getting things rolling, right? So sketches. Sketches are the programs that we use to make our program work. So it's like the PDF of Arduino, right? Without that sketch, you really can't do much with it. And when you have a sketch, you can import your own files from other places. You can do zip files, INO, and PDEs. I prefer to have you put in the zip if you happen to have the code, example code to download. Zip tends to have a few different elements baked into it to make sure that it's working. INO is just the sketch itself, and so I'll explain in a minute why that would be important. So I'm going to go ahead and just do a new sketch to show what a blank canvas looks like on here. Now I have my Arduino plugged in, and it says it doesn't know what's going on. Well, it's because I have a third-party Arduino board. Open source, it's fine. Most of them work that way, are perfectly compatible. So I'm going to tell it it's an Arduino Uno because that's what its compatibility is designed for. It's there, it's ready to go. Now, so just to make sure things are working, I'm going to do a really basic example. So over here we have files, that's what we just created. Examples, this is for example code. We don't want to rewrite the book every time we need to get code put in place. That foundation has been laid ahead of us for quite some time, so let's not worry about that as much. And let's use examples. It's totally fine to do that. So here I'm going to go ahead and click on Blink and say, I'm just going to copy it to my sketches. So it's basically making a brand new one, because whenever you do example code, that's what it does. This grayed out line means that it's commented. Comments are awesome. If you download example code and it doesn't have very many comments, I hope you know what you're getting into, because the comments are the things that help break down what the code is about and how to work it. A lot of times when you see example code, certain things might be commented out. So example here, this void setup, it might have a void setup for one type of sensor and another void setup list for a different chip or a different microcontroller. So sometimes you might have 5 void setups with these, with them commented out, and it will say uncomment to make this work. So if I uncomment, now it's back alive, right? So if I'm looking at this run, void setup is, there's 2 different sections in most of our sketches, a setup and a loop. The setup is telling the board what it wants to do with all of its stuff, right? With all the different devices. So it's saying pin mode. Okay, so I'm telling it what the mode of the pin is going to be. What do I want that pin to do? It's called LED bulletin, and it's sending out a signal. It's making the light shine. Okay, if it was input, that means I would be sending a 5-volt signal into the Arduino board. Loop function runs again over and over again forever. Digital write. I want to set the LED to high for 1 second. Then I want to set it to low for another second. So this is basically a blinking light every second. If this was working correctly, I would always set this checkbox to verify. This will help me determine my code to make sure I didn't make any issues. If I made a mistake, like I take out the semicolon and verify, this is a really easy error to make and a really easy one to fix. So that's great. Oh, there it is, right? So I need to, it says it's expecting something. If you have your credits for the day, you can get free AI fixing of your errors here on the cloud. However, those are limited on a free account, so you can only do that for so often to get a more specific error code. Using other AI tools, ChatGPT, Microsoft Copilot, those tend to be pretty helpful too if you're in that position. So I fixed it. I'm going to go ahead and hit the arrow to download it, and it will send it through. As it downloads all the way through, now my Arduino light will be blinking and doing its job, right? So program downloaded, success. I'm going to look at one other sketch with you to kind of show one of the bigger concepts to grasp, and that's going to be for our devices that don't have everything all built in. That example had a basic Arduino example. So I'm going to go ahead and say I have the Uno. Now it's example code, so I did the exact same thing, and this is from a library, the DHT11 library. So that library is all the code in the back end that makes devices work. So if I say DHT11, there might be a lot of different DHT11 sensor manufacturers. So sometimes picking the exact one might make the difference between having something work and not work. So make sure if for some reason something isn't quite working and everything else is in place, to just check your double check your library, or just try another one. Every library, good library, will have an example pool. So here's where I grab this one, read temp and humidity, read temp and humidity. I have it downloaded and ready to go. If I was to click on the example, it would open a new sketch and allow me to modify it. If you're going to do the same sensor a lot, you can star it, put in your favorites. It'll keep that handy for you. Here's the notes. We're at the very beginning, it's including this library, so it knows to download that library for this program. Down below, here it says to create an instance for what DHT11 is doing. We're doing Arduino, so connect the sensor to digital I/O pin number 2. If you're using different boards, here's where those notes are handy again, showing you which pin it needs to go into. And then here it's saying you're going to set up the DHT to pin 2. If you wanted to use pin 3, change it to 3. That's stuff that we want our students to be able to eventually grasp and take control of, because sometimes their designs will need different pins for different things, or just for convenience they can change the layout, right? Here's our setup. Serial begin. This is the baud rate for the serial monitor. I'll show you that in a second. And then here's that uncommon example to set the custom delay between sensor readings. So in this case, it's set to a 2-second delay. That's what the sensor likes. Anything more than that might make it angry. Here's our loop, right? Loops are going to be the meat of what the code is actually doing, right? So you can see this bracket here, and I click on it, and this one down here is highlighted. This is going to be one of the biggest errors you'll run into if you're new to coding and if you're writing your own code. Everything that's in this group is running in that loop. However, there might be some little commands or actions inside here that you need to pay attention or to write in between. So here's another example from here to here. Notice this highlights. This is the execution of the code in this particular instruction, from this bracket to this one. When a new bracket is introduced, it's doing a new process. So if you ever see, like if you reverse this from pointing to the left to the right, or vice versa, then it might make the program angry. I'm going to go ahead and download this so that we can see the serial monitor. So it's running through your serial monitor. And I don't have my sensor plugged in, but as soon as the program is downloaded onto the machine, there it goes, then it should be running it through and playing the code through. Now, go ahead and run it one more time. There we go. So now it's running through, and it should be sending a signal to my computer through the serial. I don't have my sensor plugged in, so it's saying error. But here, where if I had the word temperature, that's what I typed in, then it would be reading, it would say the word temperature and the actual variable right after that, right? It would give me those units. And every time that line comes over, it's giving me a new line. If you get a bunch of gibberish, so for example, if it looks something like this is a pretty common issue. You'll see it, a bunch of weird characters going through. It means your baud rate is not properly synced with your Arduino. So if you're trying to troubleshoot and you're having an issue, make sure that this measurement is the same as the setup in this in your setup at the beginning in your void. So now I got it back and it's working well. So that's the gist of it. As far as the general quick layout of the code, like we said, we're trying to build these code sets so that, and hopefully the comments and the notes will be handy enough. We'll keep updating them as needed to make sure that they are clear for everybody and that it's really as easy to use as possible. And we hope that this gets you at least a first step on getting those things going. If you can download and execute code, you're ready to start off your experience with different types of Arduino experiments and projects. So good luck, have fun, and hopefully you can come up with some pretty cool integrations with all these different options that we'll have for you.